Hello, I have been asked to introduce the Frame Management Group to you. The Frame Management Group is part of worldwide networks, and one of their responsibilities is the main distribution frame within exchanges. This is commonly called the MDF. The MDF is the key connection point between the exchange and the local network. With exchange modernization, exchange faults are on a downward trend, and MDF faults are becoming more significant. People are the only moving part on the MDF. Unfortunately, since MDF faults don't just normally occur, we have to accept that they are generally put on by frame users. Worldwide networks are tackling this problem by firstly reducing the number of people who need to work on the frame, and secondly, they are ensuring that those who do so are fully trained. Let's look at a typical fault which will involve a visit to an exchange MDF.
Our story begins one morning when Mrs. Jones went to use her telephone. Alas, it didn't work. With the neighbours all out, her nearest telephone was the telephone box up the road. At the telephone box, Mrs. Jones makes her call, after which she dials 151 to report her telephone out of order. Naturally, she wants her service restored as soon as possible. Once through to the RSC, the engineer is able to test Mrs. Jones' line using the CSS line test. In this case, we see poor Mrs. Jones has a fault on her line somewhere underground. The fault is passed to the UG Maintenance Control, who radio John, our UG Maintenance Engineer. John makes his way to the cabinet, where a few tests are made. In some cabinets, John could be presented with a notice informing him that golden pairs exist, or that the exchange has been pre-jumpered. In either case, an exchange visit will not be necessary, but he must follow the instructions on the notice. This fault is proved to be a dis on the E side, which will require a new routing. A new jumper as well, I shouldn't wonder, thinks John. He now makes his way to the local unmanned exchange. There he'll find the main distribution frame, or MDF, to the point where the faulty line terminates. On arrival at the exchange, John is required to sign the exchange diary, after which he contacts the Routing and Records Office for a new route for Mrs. Jones' line. The frame that he's about to work on is a rack type. This is only one of many types in use today, each having a different jumpering technique. Current developments have produced our modern cosmic frame, which we'll look at after we've sorted Mrs. Jones' problem out. There are also many different types of block to be found on our frames, from the old 20-way gate-type blocks through to the later 100-way blocks, all of which use the wrap and solder joint for termination. Modern frames have now provided us with the new insulation displacement technique, or IDT, for completely solderless joint. We'll be seeing how John deals with the two types of terminating method. Back to John, who has now checked that his new bar pair is spare and tests OK, and has also identified the faulty pair on the line side of the MDF, and with it the jumper to be recovered. To recover the jumper, he cuts the wire, leaving half-inch tails on the tags. He now grips the wire of one leg using pliers wiring number 2. When the solder begins to flow, he unwraps the tail and carefully removes any excess solder. He repeats this for the other leg of the pair. He ensures the tags are clean and tinned ready for the next jumper once the fault has been repaired. On the exchange side of the frame, the jumper is terminated on an insulation displacement block. To remove a jumper from this type of block, John must use his extractor 5/8. By placing the extractor into the hole on the front of the block, associated with the circuit, he slowly turns the tool clockwise until he feels the jumper engage the slots at the end of the tool. He continues turning the tool until resistance is felt against the wire. John now gently pulls the extractor towards himself until disconnection is complete. He cuts off the sharp, distorted ends and feeds the wire back through the block, ready for recovery. To recover the jumper, he pulls it slowly and evenly from the frame so as not to burn any other jumpers, then discards all the scrap wire. Having recovered the old jumper, John can now run in the new one, normally from the exchange side of the frame. Here we see a route that a jumper would normally take. Under the jumper field, it has been run to a block directly opposite, or from within a frame unit. This is clearly identified by the red marker. In John's particular case, however, he's required to run his jumper in a rack-type MDF. This he does from the exchange side to line side in the following manner. From one rack to another, the jumper is passed through the lower ring on the required level, as shown. It's then run along the horizontal to the block required, where it's passed through the lowest possible uncongested hole. This is demonstrated by the red marker in the jumper field. Having routed the jumper within the MDF, John now threads it through the fanning strip at the back of the block associated with his circuit. Using strippers number 2, John strips the wire, ensuring each leg is cut to its correct length for its appropriate tag. Using pliers, wiring number 2, the conductor is positioned so that the insulation stops just short of the tag. He then wraps the wire around the back notch of the tag 1.5 times, removing any surplus wire. This operation is then repeated for the other leg. The circuit is now ready to be soldered. With the iron at the correct temperature, he uses the minimum amount of solder to flow over the connection. With both legs soldered, the jumper is dressed back into the block. On the exchange side, John cuts the wire, ensuring there's plenty of surplus. He feeds the jumper through the correct hole on the right-hand side of the block. At this point, slack is introduced. 2 inches of slack for jumpers under 10 yards, 4 inches of slack for jumpers over 10 yards. He feeds the correct length of slack back through the block and into the jumper field. Here we see the ends of the jumper, A leg up, the B leg down, fanned across the face of its tags, ready to be terminated. To terminate on these blocks, an inserter 8A must be used. Note the white transfer markings on the inserter showing the correct way up to use the tool. When using the inserter, John positions himself in front of the block and supports the block with his free hand. Using sufficient pressure, he firmly inserts the wire into its tag, ensuring a good connection. Rejumpering now complete, John must test his work and replace all relevant fuses or protector modules. John is now able to confirm with Mrs. Jones and his control that the line is now working. All work complete, John must fill in the details in the MDF logbook, or, if he's unable to do so, he rings the FMC so that the frame management staff can update the exchange records. Let's now look at a recovery and a reprovide on a modern cosmic type frame. It's important to note that the 950 BC is the only tool to be used on a cosmic frame. It combines an inserter, an extractor, and a cutting tool all in one unit. This will be found on site and should never be removed. With the hook pointing down, John puts the extractor over the tag and behind the wire, and with very little force pulls the wire off. He does the same for both legs and for both ends of the wire. He now cuts off the sharp, distorted ends, ready for recovery. To avoid the slack of adjacent jumpers bunching in the jumper field, the jumper must be recovered from within the vertical jumper trough, or VJT. John can now run in his new wire, making sure he uses 8000 series jumper wire, which is thinner than normal wire. It can be identified with a violet tracer and must only be used on cosmic frames. Using the cutter part of the inserter 950, the 2 legs of the jumper are cut to a difference of ½ an inch in length. Having cut the wires, John inserts one leg of the jumper into the hole in the head of the tool and bends it across the slot, ready for terminating. He aligns the wire into the correct slot on the tag and with a small amount of pressure pushes the wire into the slot, and does the same for the other leg. To enable maintenance duties to be carried out on the back of the cosmic frames, John must allow 10 inches of slack to be stored in the vertical jumper trough as shown. The other end can now be terminated. Once complete, John must again test his work, replace the protector module, and confirm that all is once again back in working order. Minimum requirements when working on an MDF. Do not visit an exchange if there is no need. If you do, sign the exchange diary, ensure records are amended, and or the MDF logbook is completed. When working on the frame, use the correct tools. Use the correct wire, run jumpers correctly, terminate jumpers correctly, remove ceased jumpers with care, leave tags clean. Comply with safety requirements. Leave the work area free of discarded material. Ask for further training if required.
You have seen here some examples of good working practices to be followed when working on MDFs. Your manager has agreed that these minimum standards are required when working on MDFs. A copy of the concise jumpering guide will be found in the MDF logbook. Your manager has a copy with him today for you to see. A one-day MDF course supporting this video is run by the Frame Management Group, and they will be pleased to arrange training. Ask your manager for details. Thank you for listening to this presentation. By following the methods shown in this video and on the training course, MDF faults will be reduced, thus ensuring customer satisfaction. Thank you again.